This is the Unit 2 review. We're testing on Wednesday. September 28th. Okay, so before we start, I want to clarify something. The absolute value measures the distance a number is from zero. That's why the absolute value can never be negative, because distance is never negative. So if I wanted to know the absolute value of -5, I'm thinking, how far is -5 from 0? -5 is 5 units from 0. So that's when we graph our parent function, the absolute value of x. No matter what x is, y is going to be positive, because the absolute value of all these negative numbers is a positive number. So absolute value of 0, 0 is not negative, it's not positive. 0 is 0 units from 0. So how far is 1 from 0? 1 is 1 unit from 0. -1. -1 is 1 unit from 0. So thing with 2, -2, all these negative numbers are going to be mapped to the positive y-axis. Because no matter what you have, it's always going to be a positive value. So -2, -3, -4, -5. Ooh. -5. And I'm going to get a ruler and just connect my dots. So the absolute value is all these points along that diagonal. It's going to look the same in the first quadrant. So that's my graph. So my domain, I'm looking at every single number possible. So the domain is going to be all real numbers. I'm considering every single x value. My range, I can never go negative. So I'm starting from 0 and I'm going up. So all these y values are greater than 0. So my range, y is greater than or equal to 0, because 0 is a point along my graph. That point, my vertex, 0, 0, is my minimum. So I have no point below. And then symmetry, I could draw a vertical line right through my vertex. That vertical line is going to be the line x equals 0. Because along this line, my y value changes, that's the y-axis, but every single point along that line has an x value of 0. So my symmetry is that line, x equals 0. So all these points are equidistant from that line. Like -2 is 2 units from that line. 2 is 2 units from that line. So it's symmetric about that line. And then my x and y intercepts, it crosses the x and y axis at 0. So it's 0, 0, 0, 0. The only tricky thing is my intervals of increase and decrease. This line I am dropping down, I have a negative slope. And on this side, I have a positive slope. So if I'm coming down, that's decreasing. And then I go up, so I'm increasing. So my interval is in terms of my x values, but the matter of increasing or decreasing is my y values. If my y values are decreasing, then I consider those x values from negative infinity, way out over here somewhere, up until that line, x equals 0, I was decreasing. Then after that, I'm increasing from 0 all the way out forever to positive infinity. So number 2, again, the domains, all real numbers for absolute value. I need to find my vertex. So from my graph, I can look at the inside, the x minus 2. X minus 2 goes to the right 2. So my vertex would be at 2, 3. And you can find that from the graph. If you just put this equation in the calculator, you could find the vertex 2, 3 from the graph or from the table. So I'll go over here and plot 2, 3. So go over 2, up 3. So there's my vertex. And then from the equation, the negative 1/2 tells me my slope. So from my vertex, I'm going down 1 over 2. Then I'm going to get my ruler and draw my graph. And so if all my y values are below my vertex, I have a maximum. And my y is less than 3. That's my range. All these y values along my graph are less than 3. And then my symmetry, I can draw a vertical line through my vertex. And that's x equals 2. So my symmetry is x equals 2. So every single point is equidistant from that line. So 0, 2 is 2 units from that line, and 4, 2 is 2 units from that line. And then increasing and decreasing, I have a positive slope, and on this side I have a negative slope. So I increased until I got to my vertex, and then I started decreasing. So this side's increasing. This side is decreasing. So increasing, I started out somewhere around negative infinity up until that vertical line, x equals 2. And then from 2 on to positive infinity, I decrease. And these two intervals have to be opposite of each other. These two intervals have to give me the real number line. So that line of symmetry cut it in half, but it's the whole real number line, because my domain, my x values, are all real numbers, everything. Number 3, I'm not subtracting or adding anything from 0, or from x, so my x coordinate of a vertex is 0. And then my y is negative 4, so that's my vertex. So 0, negative 4, and that 3 out front tells me my slope. So from there, I'm going up 3 over 1, up 3 over 1, Okay, and that's my vertex down here. 0, -4. And that value is the bottom, that's a min. So my range is everything above -4. So y is greater than or equal to -4. And my symmetry, again, is the y-axis, like number 1. The y-axis, x equals 0, cuts my absolute value function in half and makes it's symmetric on either side. And so again, the increasing and decreasing looks like number 1 because it's facing up and the y-axis cuts it in half. So it's decreasing from -infinity to 0, and it's increasing from 0 to +infinity.